Good morning, students. Good morning, all of you. Did you get the notification? All of you, just inform me. Did you get the notification of this video? Okay. Rathul Shahil Sharma has not got, because in my mobile also the notification has not come yet. That's why I'm asking you. You have not got. Okay, you have not got. In my mobile also the notification has not come. It has not come yet. Maybe any network issue. Maybe any network issue. In my mobile, the notification of this video has not come yet. Maybe any network issue. Okay, Silas saying, sir, from 2-3 days, the notification is coming late. Maybe network issue or something else. No idea. Because in my mobile also the notification has not come yet. It has not come, and this is the first time happened. First time. I'm taking this live classes since last 2 months, but around around 60 live classes I have taken in total. In total, 60, 65 live classes I have taken, and this is the first time. This is the first time that the notification has not come. In my mobile only, the notification has not come. Okay. By the way, where are the others? All of you join first so that we can start household circuit. Where are the others? Yeah. Good morning. Good morning. Jasraj has come now. Good morning. Jasraj, did you get the notification? Jasraj, did you get the notification of this video? Arey, Jasraj is also saying no. He has also not got. Okay, the notification has not come, but no problem. Where are the other students so that we can start our chapter? Not starting. We are in the fourth session of this chapter, session 4. Okay, live session 4. Okay, Tapabrata is also saying that sir, I have also not got. I have also not got. You know what? I told you, na, this is the, I think this is the 65th, means 65, 60 to 65 live classes are taken it. But this is the first time happened with me that I have not got the notification of this video. So that's why I'm asking you. I don't know, maybe a network problem. Now the thing is that, so as you know, we are in the fourth live session of the chapter household circuit. Okay, household circuit. Fourth live session. But where are the others? Where the others so that we can start? Okay. Sir, it is happening with many YouTubers. Notification will not come in between or end of the stream. Okay, but this is the first time happened with me. Earlier, Nilesh used to tell me. Now, where is Nilesh? He's absent. Nilesh Dev was absent. Nilesh used to tell that he is only he's the person. Only he's the person who was not getting that notification. But now I'm also not getting the notification. Okay, so in household circuit, this is the fourth session of household circuit, and I hope you remember. I hope you remember that in the last live session, at the end of last live session, I told you about that in the staircase. In the staircase, that the bulb is there in the mid of the staircase, and one switch we connect at the top and one switch we connect at down. Okay, two switches are there. You remember that case? Of course you remember that staircase. In the staircase the bulb is there, and at the up at the top we connect a switch, and at the down of the staircase we connect another switch. And both the switches, by using both the switches, we can operate the same bulb. Do you remember that? Both the bulbs, the same bulb is operated by both the switches. This connection we'll see now. First we'll see this connection. Okay, I'll show you that. So if I draw that case, I told you that if I draw that case like staircase connection, this is the bulb which we connect. I'm sure that is connected at your home. This bulb is connected at your home, and two switches are there. One switch is at top and one switch is at bottom, and both the switch we use to operate the same bulb switch on or off. We do that. You remember, I think. Acha. So switch 1, switch 2. Now just first of all, you just confirm me, is it clearly visible? Just tell me, is it clearly visible to you? Okay, fine. Now see, here is switch 1, here is switch 2. Okay, this is switch 1, this is switch 2. And both the switches we on or off to operate the same bulb. Same bulb can be switched on or switched off by using the two switches. Now I'll show you the connection, and I'm sure this type of connections are already fitted at your home. Okay, your electrician has done that. If you have staircase at your home, then your electrician, I'm sure that he has done this connection. Now, how to connect those bulbs? If you want to connect, you can also do that. I'll show you that connection. For that, you have to get two switches. Okay, you have to get two switches, the special switches, not that normal switches which we connect for bulb or fan, not those normal switches. Two switches we have to get. And if you ask the electrician, if you ask the electric shopkeeper that I want the switches, dual control switches or dual switches, you got my point? Dual switches or dual control switches. If you buy those switches, two switches, easily you can do this connection. I'll show you that. And one more thing I shown you before, that is switch. In switch, how many points are there? 3 points are there. Okay, first point, second point, and third point. So I'm drawing a switch here. See, I told you inside a switch, 3 points are there. Either you have to connect these first 2 points or you have to connect these last 2 points. Okay, if you connect first 2 points or you have to connect last 2 points. Okay, so dual control switch, we have to take two dual control switch. So I'm taking 2 dual control switches. I'll show you the diagram. Okay, 2 dual control switches I have taken. Say this switch at top and this switch at bottom. Okay, now the bulb is there. Okay, the bulb I'm connecting. I'll show you the connection first. Say this one. Try to understand this connection. Say here I am taking 2 dual control switches. As I told you that dual control switches are required. This is the first switch. This is the second switch. Okay. And from here the electricity is coming, because electricity you have to supply to function the bulb. To this is the electricity supply, and one wire is connected with the bulb and other wire is going to from the bulb to the mid of the switch, and from source also it is coming mid of the switch. All of you see this connection very carefully, very carefully, because in the exam hall we just forget that which connections, which to connect to which. Okay, what to connect to what, we just forget in the exam hall. So see this connection very clearly. So see, from the source it's going to bulb, and from the bulb it is coming to mid of the switch, and here also from the source the mid of the switch is coming, and top of the both the switches are connected with a wire, and top bottom of the switches are also connected by a wire. These are already connected. So this is the connection of dual control switch. Okay, dual control switch. Only what is left, I have not drawn that either these two will be connected or these two will be connected. Okay, I'll show you that. See this, these two are connected and these two are connected. Okay, these two are connected and these two are connected. I told you either you can connect these two or you have to connect these two, because switches are designed in that way only. We discussed that day. Either you have to connect these two, that first and second, or you have to connect second and third. So here I'm connecting second and third, and here also I'm connecting second and third. So now tell me, is this circuit complete? Is this circuit complete? I mean the bulb will glow. Just answer me once. Is this circuit complete? Is the bulb will glow? Is the bulb will function? Just write me in the comment, what do you think? Just check whether circuit is completed or not. Circuit is completed or not. Just check. Okay, like maximum students are writing circuit is completed. Only Priyansh Kumar is writing no, circuit is not completed. Okay, let's see whether circuit is completed or not. Just start from here. Okay, start from here. So it is going because we know one point is plus and one point is minus. No electric source, one point is plus, another point is minus, and from plus current goes to minus. Let's see this circuit is complete or not. So see, from plus current is going. Yes, from plus current is going to minus. From plus current is going to minus. Okay, see there. From plus current is going to minus directly. Understood? So means circuit is completed. Circuit is completed, the bulb will glow. Circuit is completed, the bulb will glow. Understood? Means both the switches are on. So just draw this circuit. All of you just draw this circuit and write here both the switches are on. Okay, write it. Draw it and write here both the switches are on. Okay, let's see. Priyanshu Singh Rajput, hello sir. कौन सा chapter है sir? This is chapter household circuit or electricity also you can say. Which class you are in? Priyanshu Singh Rajput, which class you are in and which board? CBSE or ICSC? Priyanshu, which class you are in and which board? ICSC or CBSE? So I hope you understood this circuit. I hope you all understood this circuit. The circuit is completed. From plus, we saw that all are connected. So circuit is complete. So both the switches are on. So all of you draw this circuit, and right here switches, both the switches are on. Okay, both the switches are on. Fine. Now I will show you another circuit now. I will show you another circuit now, and you have to answer me that circuit is complete or not. If circuit is complete, the bulb will function. Circuit is complete or not. So you understood that how you have to connect this type of connection at your home. Easily you can also do that. Just you have to buy two switches, two dual control switches that is available in electric shop, and wire you have to take, and then the bulb. That much. Easily you can also do that. Now see this circuit, all of you. All of you see this circuit and tell me that see this circuit and tell me that is the circuit complete? Is the circuit completed? Is the bulb glowing? Just let me know whether the circuit is completed or the bulb is glowing something. Circuit is not complete. Okay, you are saying no, sir, the circuit is not complete. Because from plus, let us move. Start moving from plus. It's going, see, it's going, going. Oh, here it is broken. See, here it is broken. Okay, it's broken here. So it's not connected here. That means this switch is off and this is on. Okay, this switch is off and this is on. Understood? So I can say that this switch is on and this is off. Okay, the circuit is not completed. Try to understand. This switch is on and this switch is off. Okay, see. Understood? So in the same way, I can also say that if this one, acha, first you draw this, all of you draw this, after that we'll discuss. First you draw this circuit, that this switch is on and this is off. Draw it first. Done? Okay. Now, again, I'm drawing another circuit. Just tell me this circuit is completed or not. So as I told you, you can also connect this circuit easily, very easily. If you know the connection and if you buy the switches, easily you can also go for this connection and easily you can save, if you call an electrician, the electrician will come and he will let you know the things, he will connect the things, and he will take at least 400 to 500 rupees for this connection, 400 to 500. So easily you can do that and you can save that money. Now I'll show you another circuit. Just let me know that both the circuits are on or off. The circuit is completed or it is not completed. Now what I've drawn, this circuit is just opposite of the previous circuit. This circuit is just opposite of the previous circuit. Just let me know whether this circuit is completed. That means the bulb will glow. This circuit, the bulb will glow. Is the circuit complete? Okay, just as said not, sir. No, it's not completed. Okay, other students, what do you think? Circuit is not completed. Yes, the circuit is not completed because from plus you start. This is going. Oh, disconnected here. So circuit is not completed. Okay, circuit is not completed. So here the first switch is off and the second switch is on. See, yeah, the first is this one, the opposite of the previous circuit. Okay, so in this way. Come on, draw it. All of you, draw it. Draw it, all of you. Okay. Okay. So understood, I hope. So both the switches you can operate by the switch which is connected at bottom, on off, or the top one also on off you can do. Okay. This is the connection. This is the connection, dual control switch, or we call it staircase connection. Staircase connection or dual control switch. Okay. We call it dual control switch or staircase connection. Don't forget this. It's very important. It comes in the exam. Now, if we call an electrician, like, as I told you that day, say you made a building, you made a house, your own house, and you are calling electrician. Okay, you called electrician that I have all these devices, fridge, washing machine, TV, fan, bulb, all this you have got. Now you require electric connection for that. So to have the proper electric connection, you have to call an electrician, and you are asking electrician that what do you require. Is saying you that I required wire, I required tapes, all this they required. So where they will tell you that you bring 10 coils of wire. Okay, 10 coils of wire, because he requires huge amount of wire to connect all the rooms. Okay, all the appliances. So he will ask you that say 10 bundles of wire I required. 10 bundles. After that, he will tell you, don't bring all these 10 bundles in same color. Okay, he will tell you, don't bring all these bundles in same color. He will tell you 3 different colors to bring. Understood my point? He will tell you 3 different colors to bring. Okay, why 3 different colors? The first one is for live wire, neutral wire, earth wire. These 3 wires he requires. So he will tell you to bring 3 different colors. Okay, so that easily he can connect. Now, what is the problem if you bring the same color for all? Okay, say you bought green color for live, earth, neutral. All these are 3 same color. No harm. It will make no difference. It will make no difference for the connection. Same connection will be taken place. But for the sake of electrician, so that he can connect the things easily, that's why electrician will tell you to bring 3 different colors. Understood? Just sake of electrician means so that just to make the electricians work easier, he will tell you to bring 3 different colors. Okay, now generally we use the colors for different colors for connecting the wires. Actually, previous days, the early days, we used to different color, and these days we are also using different color, but the colors, the shade are changed. Okay, the shades are changed now. So it's an important question for your exam. Just write this question. All of you write this question first. What are the color coding? What are the of color coding of wires? What are the color coding of wires color coding of wires of an electric connection, of an electric connection. Okay, written the question. What are the color coding of wires of an electric connection? Okay, now the thing is that as I told you that early days we used to use different shade, and these days we are using different shade. Okay, that is called old convention and this is new convention. Okay, so write in the answer old convention, old convention, old convention. You have written, underline it, underline. Okay, now write live equal to red, live equal to red, neutral black, earthware green. These are the color we used to use before. Okay, live red, neutral black, earth green. These three shades we used to use before. That is called old convention. But according to new convention, write new convention and then give underline. New convention and give underline. Okay, new convention. Live equal to brown. Yes, now we use brown. Live equal to brown, and neutral equal to light blue, light blue. Earthware equal to green or yellow, green or yellow. Okay, so these are the color coding of electric connection, earlier days and present days. Okay, it's an important question for your exam, and in the question it will be mentioned, that old convention or new convention. What do you have to write? That will be mentioned. Okay, old convention or new convention, don't worry, that will be mentioned. Okay, if both comes, then you have to write both. Now so this is the thing. Now, but practically if you call an electrician at your home and if you ask to make the connection for live wire, neutral wire and earthware, they will not tell you that these are the colors you bring. Okay, they will tell you any three colors. Means don't expect, you don't expect that they will say you all these colors which you have written now. Don't expect that they will tell you, because they do not know all this, they do not know all this, they do not require also. They are much expert, they are higher, their expert level is much higher. So they will tell you that three wires, okay, three different color they will tell you, and accordingly you have to bring. Okay, accordingly you have to bring. What I have observed when I was having an electric, recently I had an electric connection at one room, electric connection. So when I called the electrician, he gave me three different shades. Okay, live and neutral are not matching what you have written here. Yeah, the earthware was matching. For earthware he said green. Okay, earthware he said green. Live and neutral he said different colors, but earth color he said green, to bring green color. Correct? So this is the thing. Now, as I told you, as we discussed in our last live class, that fuse wire. You know fuse wire. What is the function of fuse wire? You know all this. Okay, And where do you connect fuse wire? Yes, we connect fuse wire with the live wire. With the live wire, we connect fuse wire. Correct. So fuse wire is something, a simple wire. Fuse wire is a thin, simple wire. Okay. I'm telling you, just you have to keep it here. Fuse wire is a thin wire which is connected with the live wire, so that when a huge amount of current enters, you know that when current passes, it produces heat. So that thin wire also get heated up and it melts and circuit breaks. You are saved. Okay, so fuse wire saved you. Okay, that is fuse wire. But when we go for an electric connection at one room or a complete house, or any room, when we go for an electric connection, then we use several fuses, one or two or three. Like in your house, at least three fuses are there. At least three fuses. More fuses you can connect, but at least three fuses are there. Just count once. At least three, not less than three. At least three fuses are there in our home. At least three. More than three are also there, but at least three. Now, all these fuses are connected. Okay, all these fuses are connected. Now, there is an important thing which we call rating of fuse. Okay, rating of fuse. Now, what is the meaning of rating of fuse? Listen very carefully. Rating of fuse means a fuse wire through which what is the large amount of current allowed to pass. Okay, that is called rating of fuse. Not understood? Listen again. Rating of fuse means through a fuse wire what is the large amount of current will pass. Say the rating of a fuse is 5 ampere. Understood? Rating of a fuse is 5 ampere. That means through that fuse, maximum 5 ampere of current can pass. If 5.1 or 5.2 ampere current passes, the fuse will melt. Okay. Now, say in a room, say AC is there, TV is there, then electric bulb is there. Okay, electric bulb, TV, AC. These three things are there. For these three things, you have calculated that 9 ampere of current is required. Okay, 9 ampere of current is required. So you have connected a fuse of 10 ampere. That maximum 10 ampere current will pass. Okay, so if the current exceeds from 10, the fuse will melt and your devices will be saved. But just imagine, instead of using 9, so 9 ampere current is required. Okay, 9 ampere current is required. So you required a fuse of 10 ampere. But instead of connecting a fuse of 10 ampere, if you connect a fuse of 15 ampere, then if a large amount of current enters, it can easily enter to that room and it will harm your AC, your TV, your bulb, everything. You understood my point? So there is a rating of fuse. Every fuse, there is a rating. Rating means the maximum amount of current allowed to pass through that fuse. This is called rating of the fuse. If the rating of a fuse is 10 ampere, means a maximum of 10 ampere current can pass through that fuse. Okay, this question comes in the exam. Now, so write this question, all of you. Write this question. The rating of a fuse is 15 ampere. The rating of a fuse is 15 ampere. What does it mean? The rating of a fuse is 15 ampere. 15 ampere I said, no? The rating of a fuse is 15 ampere. What does it mean? इसका क्या मतलब है? इसका मतलब हुआ कि rating of a fuse, write the answer. Write the answer. Rating of a fuse is 15 ampere. Rating of a fuse is 15 ampere. This means rating of a fuse is 15 ampere. This means maximum 15 ampere of current. Maximum 15 ampere of current can pass through that fuse wire. Can pass through that fuse wire. Full stop. If the current exceeds the fuse wire will melt. If the current exceeds, the fuse wire will melt. Okay? If the current exceeds, the fuse wire will melt. Fine. Next question. All of you write one question. An AC. Write one question. An AC. An AC is rated. An AC is rated 3 kilowatt kW. 3 kilowatt kW. An AC is rated 3 kilowatt, 250 volt. 3 kilowatt kW, 250 volt. Full stop. Give reason whether this AC, give reason whether this AC can be used in a circuit, containing a fuse of rating 12 ampere. Fuse of rating 12 ampere. I hope you have finished writing the question. So what is the question? The question is AC whose rating is 3 kilowatt. So you bought a new AC for your room. Okay. For your room, you bought a new AC, and at the back of the AC you have seen it's written 3 kilowatt. Okay. And 250 volt. Fine. And the fuse which is connected in that room is 13 ampere. Okay. 13 ampere. Now, whether this fuse will function or not, that you have to find. Okay. So simple formula we'll use. P equal to VI. Do you remember this formula? This formula I told you in the chapter electricity. Electricity, we discussed this formula. P equal to VI. So use that formula P equal to VI. P equal to VI. What is P here? 3 kilowatt. 3000 watt. Yes. Kilowatt has to be converted into watt. 3000. So 3000 equal to V. Now what is V? 250. What is I? I we do not know. I will find. I is what? 3000 by 250. That is 3000 by 250 is 12 ampere. 12 ampere equal to I. Now, what was the question? Give reason whether the AC can be used in a circuit which containing a fuse of 13 ampere. No, fuse of 13 ampere. So the answer is yes. This fuse can be used in, yes, this fuse can be used in 13 ampere, because how much, current is required? The current is required 12 ampere. Current required for the AC is 12 ampere, but here the fuse rating is 13 ampere. Okay, so since the fuse rating is 13 ampere, and the AC requires 12 ampere, so easily it will function. Understood? So in this way we'll do it. We'll do it in this way. Say P equal to VI. P is 3000 watt equal to 250 into I. So I equal to 3000 by 250. So just divide it, 12 ampere. Okay. Solve it. If you have solved it, fine. If you have not solved, solve it now. Okay, solve it now. So, how much current is required? The current is required for the AC is 12 ampere and the circuit, the fuse is 13 ampere. So it will work. It will work. Okay. Now one more question that will be solved by you. I will not solve it. Or a logical question I'll ask. Just answer me. One logical question. Two fuse wires are there. Okay, two fuse wires are there. First fuse wire is 5 ampere and second fuse wire is 15 ampere. Understood? First fuse wire is 5 ampere and second fuse wire is 15 ampere. Which is thicker? Which is thicker? 5 ampere or 15 ampere? Which fuse wire is thicker? Just answer me. 15 ampere is thicker. Just think on this. And those who are writing 15 ampere, just tell me why do you think it's 15 ampere is thicker? Why do you think 15 ampere is thicker? Just give the answer. Why do you think that 15 ampere is thicker? Justify your answer. Okay, let's see. Ratul Karma has written 15 ampere is thicker because the current passes is more. Okay, more area of cross section. Correct. Both the answers are correct. Both will get full marks. Ratul and Mritik both will get full marks. They use the logic, since the wire is thicker. Wire is thicker means resistance is less. Cross sectional area. Do you remember that? The factors on which resistance depends. When the wire is thicker means cross sectional area is higher. When a higher cross sectional area means less resistance, means more current, more 15 ampere. Yes, correct answer. Very good. Both the answers are correct and both are getting full marks. Okay, now one question. After that, we'll finish the class. One numerical you will solve, then finish the class. Just write down this question. 110 bulbs, 110. 110 bulbs, each 5 watt, each 5 watt, each 5 watt. Understood the question? I repeat, 110 bulbs, each 5 watt are operated, are being operated, are being operated with an electric source 220 volt, with an electric source 220 volt, full stop. The rating of the fuse connected, the rating of the fuse connected, rating of the fuse connected is 2 ampere. Rating of the fuse connected is 2 ampere. Full stop. Is the rating correct? Is the rating correct? Question mark. Solve it and tell me the answer. Understood? 110 bulbs, each 5 watt, and the source is 220 volt. Now, how much? Yeah. What is the rating of the fuse should be? And tell me, the fuse which I have connected is 2 ampere. So is it okay? Is it okay? Is it correct? Just answer me. Just answer me. First, so that, or else I will show you the circuit. No, sir, not correct. Because I is 2.5. Yes, this is, who is this? Priyansh Kumar. Yes, Priyansh Kumar. Absolutely correct. I'll show you the solution. We know that P equal to VI. P equal to VI. P means, what is the number of bulbs? 110 into 5 watt. See, this is what I've done. See, this is what I've done. 110 bulbs into 5. Because 5 watt is the power of one bulb. 110 into 5 equal to VI. Try to understand this line. This is the main line of this sum. 110 bulbs into 5 equal to voltage 220 into I. So I, we have got 2.5 ampere. I is 2.5 ampere. So the current required is 2.5 ampere. But you have connected the fuse 2 ampere. So obviously the fuse will melt. The thing will not work. Understood? So this is the question. I hope you have solved this. Yes. The students has sent me the correct answer. Very good. So now with this, we just finish our class. Now all of you just write your name in the comment section and then you can leave the class. Thank you all. Bye. Bye. Thank you all. Just just write your name and then you can leave the class.